Geometry lesson 3-2, continuing on with proofs and theorems. We're now going to look at some relationships between lines. We're going to look at some more proofs, and we're going to look at a different form of a proof rather than just the standard two-column proof with our statements and our reasons. We can still use those, but we have basically three different forms. We've got a paragraph proof where we explain our reasoning. We have what we've been traditionally using, the two-column proof, and then today we'll start talking about another proof, which is the flow of proof. So here is our our first example. Given these two intersecting lines and labeling the angles 5, 6, and 7, we have this given information. We know that angle 5 and angle 6 are a linear pair. So if they're a linear pair, we're talking about those angles right there. We also know that 6 and 7 are a linear pair, which means these two are a linear pair. And from this, we would like to prove that angle 5 is congruent to angle 7. Now, I realize that most of you would say, well, the fact that they're vertical angles means they're going to be congruent, which is true. But we would like to be able to prove it another way. We don't want to just believe that vertical angles are always going to be congruent to each other. Let's find a way to prove that they are the same, and that way we know that the fact that they're vertical angles does in fact make them be congruent. So this is an example of a flow proof, and you'll notice that I'm going to start right here with the given information. Angle 5 and angle 6 are a linear pair. I didn't make that up. That was given. It's right here. Angle 6 and angle 7 are also a linear pair. That was also given. So I'm taking the two pieces of information somewhat separately, and from there I move into the next piece. Now, the fact that we know they're a linear pair tells us something else. It tells us that they are both supplementary. And the reason I know 6 and 7 are supplementary and 5 and 6 are supplementary, just like I'd drawn up there, is because of the linear pair postulate. The fact that they're a linear pair means the two of them are going to be making 180 degrees. Alright, now you'll notice 6 and 7, 5 and 6. There's one angle that is in common to both of them. It was also in the diagram. It's angle 6. There's an overlap of the red, there's an overlap of the blue, which means that has to be the same angle whether I'm talking about the red connection or the blue connection. This number 6 doesn't get to change. Make up a number for it that's easy. Pretend 6 is really 100 degrees. If 6 is 100 degrees for this red linear pair, then 5 has to be 80. And 6 is 100 degrees, it doesn't get to change. It's still 100 degrees with this relationship, which means 7 also has to be 80 degrees. And so the last bit of our proof, our flow proof, would be that angles 5 and 7 are congruent because of the congruent supplements theorem. If you recall that theorem from the other day, we were stating that if we have two that are supplementary and another two that are supplementary, but one of the angles is shared in both of them, then the other two have to be congruent to each other. Thus, proving that these vertical angles are in fact congruent. Alright? Now this is another proof. Then there's a theorem, which we'll just call theorem 3.1 because it's the first theorem in chapter 3. There's no fancy name for it. It has to do with perpendicular or intersecting lines. Alright? So I've got two lines that are intersecting here. One's a ray, one's a line, and then I've labeled angles 1 and 2. And I believe that these two are congruent to each other, according to the diagram. So here's the given information. Angle 1 and angle 2 are congruent. Alright, I've got the one arc and another arc. Even though they don't connect with each other, there's a single arc in both, which means that they do connect and that they are the same. I also know that angles 1 and 2 are a linear pair. You recall, a linear pair means that this right here is going to be 180 degrees. Now think about that for a moment. You have a linear pair, which means they had to be 180 degrees, and each of them are congruent to each other. There's only one thing they could be. They both have to be 90 degrees because they have to be the same and still total 180 in order to be a linear pair. We are trying to prove that G is in fact perpendicular to H. Now, I've got a whole bunch of possibilities here, and I've made a flow chart. So we're basically proving that the blue and the purple are perpendicular. I've got a whole bunch of possibilities, and I've made this flowchart, and I'm going to try to fill in the blanks as we go. Angle 1 and angle 2 are a linear pair. Well, most of us noticed that that was also a piece of given information. So I should be able to take this given and stick it here. That was given information. All right? The fact that they are a linear pair means that the two of them are supplementary, which, if you recall, I'll move these around so I can see a little better, is the linear pair postulate. So the linear pair postulate states that those have to be supplementary. Next, I have the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Now my choices are division, probably not that, another given, definition of perpendicular lines, definition of supplementary angles, substitution, definition of congruent angles, definition of right angle, or distributive property. I think the best idea here would be definition of supplementary angles. Definitions of supplementary angles state that two angles add together to make 180 degrees. Good enough. All right. Next, over here, I have angle 1 is congruent to angle 2. Angle 1 is equal to congruent to angle 2 is also given information. Move these down here so we can see them a little easier. All right, so I have some more given. Now I have gone from the congruent symbol to an equal sign. I now have added the measurement symbol in front of the two angles. That would be the definition of congruent angles. And you'll notice that that is now being flowing into the same box. So I have here the measure of angle 1 plus the measure of angle 2 equals 180. But all of a sudden it says the measure of angle 1 plus the measure of angle 1. Which means the measure of angle 2 got replaced. And it got replaced with what the measure of angle 2 equals, which is right here. So we're now talking about substitution. I substituted the value, or I put in measure of angle 1 right there. Next, here there are two measures of angle 1. Over here there's one measure of angle 1, but there's a 2 on the outside. So I've got definition of perpendicular lines, I have the division property, I have the distributive property, I have a definition of right angle. I think the distributive property is our best choice here. It's the reverse distributive property. Since there are two that are common, we can pull the two out and put what's common in the parentheses. What was common was the measure of angle 1. That's why the 2 is on the outside. So I'm down to 3. Next, you'll notice that the 2 is gone from this next box, and 180 is now 90. Both of the sides of the equal sign, that side and this side, were divided by 2. So that was the division property of equality. From there, I've gone from the measure of angle 1 equals a 90-degree angle to angle 1 is a right angle, which would be the definition of a right angle. And lastly, there's only one left, but if I have an angle 1 that's making a right angle, then G and H have to be perpendicular to each other because of the definition of perpendicular lines. So again, the flow proof started with a couple different given informations, and they came together at this point and then kind of zigzagged their way through. All right, one more, sort of similar. It's another proof. We have given that BA and BC are coming together at 90 degrees. If they're truly coming together at 90 degrees, we can put that symbol in right there just to label it. What we are trying to prove is that the two of them are complementary. Now I know they're perpendicular, and that's why I put this 90 degree in there, but that's because I know the definition of all of that. So we've got a whole hodgepodge of possibilities, and we've got to see if we can figure out where all this stuff is going to go. Well, probably a good idea would be to start with what they gave us. And they told us that BA is perpendicular to BC, and that was given information. Oops, grab the wrong one. There we go. So I have some given info. Next, the fact that I have perpendicular lines. I've got a choice of ABC is a right angle. I've got these two measurements equal 90. I've got these two measurements equal angle ABC. Measurement of ABC. Another one here. I've got these two are complementary. I think my best option is to say that I have ABC as a right angle. So my choices got a little messed up here. Let's move that out. Angle addition. Nah, that doesn't look like angle addition. Definition of perpendicular lines. That's a pretty good one. Definition of a right angle. No, that doesn't define what a right angle is. Substitution. Definition of complementary angles. I think our best choice at angle ABC as a right angle is to say definition of perpendicular lines. Because the lines are perpendicular, it means that ABC is going to form a right angle. Remember, ABC will form that right angle. Okay, now that we're at this point, I don't want to get rid of this one here so I can't see it. Next, I probably want to think about the fact that the two angles, 1 and 2, come together to form, I can put that one in next. Let's put this one in. Because it's a right angle, I know the measurement of angle ABC is going to be 90 degrees, and that's the definition of a right angle. So because it was a right angle, I know it's now equal to 90. Now let's talk about those two angles. The measure of angle, move these down here a little bit. Now I have measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. I believe that would be angle addition postulate. The two angles add together to make the bigger angle. And from here, I have measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Measure of angle 1 plus the measure of angle 2 equals 90 degrees. Where did I get this 90 from? I got it from right up here, which means that's substitution. And I've only got these two things left right here. So as far as the fact that these two add to make 90 would mean that the measure, or angle 1 and angle 2 are complementary, which is the definition of complementary angles. So we start with the given. The fact that they are coming together at 90 or coming together as perpendicular lines means that ABC is a right angle. The fact that ABC is a right angle means it's 90 degrees. The two angles add together to make ABC, which means I can plug that 90 in for ABC, and then because the two add to make 90 means they have to be complementary. So we have proven exactly what we wanted. Again, these are just some more examples of proofs, and the more you see different proofs, the more experience you get with them, the easier it becomes to kind of put them together. Don't be afraid to play around with stuff. You know, you notice I move things around from top to bottom, but basically all this stuff over here is the reasons for what we are doing, giving us the right to make these kind of statements, to say in a flowing way or a logical way to give an argument proving what we want.